Python exploratory data analysis. Exploratory data analysis is the process of getting intimate with your data. This means you understand how many rows, columns, correlations, distributions. It's not about the exact items that you do or the analysis that you do to your data set. It's more the feeling that you get when you really understand a data set. This is the starting point or the launching point that is going to lead to a lot of other types of analysis. So let's show a few examples about how I get intimate with my data. All right. The first thing I'm going to do is I'm going to use Pandas, which is a data analysis library within Python. So I'm going to import Pandas as PD, and then I'm going to create a data frame, and I'm going to do pd.readCSV because I have a data set that I would like to analyze. And if you want to follow along with this data set, you can either git clone this repo, which the data set is included, or you can just download it directly from GitHub via the browser and a file. So what we're going to be doing today is going to be the CSV tree list. And in order to actually work this, there's actually a date inside there that I want to parse, meaning I want Pandas to read it as a date rather than just read it as an object. Oops, plant date. Okay, fabulous. So first thing I always do whenever I'm doing exploratory data analysis is I look at the first couple of rows. And so in order to do that, I call df.head, and that's going to return to me the top 5 rows. That way I can check out what each of the, let me get rid of that. I can check out what each of the different columns are and a few samples for them. So I can tell that I have a bunch of NAs. I can tell that I have some plant dates here. I have some plant species, and already I'm starting to get a feel for what are these columns and what is the kind of the data structure within each one. The next thing I'm going to do is, well, I want to know how many columns and rows there are. And the easiest way to do that for me is I just call df.info, because that will tell me, 1, how many columns there are. Looks like there's 23. And then 2 is it will tell me how many rows there are, or the range index. And it looks like there's 194,000 rows. Okay, so that's interesting. I can also tell here that I have some null rows, because you can tell here it says 68,000 or 69,000 non-null rows. That means the difference between 194 and 68 is actually null. So I have quite a few nulls in this plant date. Great. Awesome. Well, the next thing I like to find out is the cardinality of my columns. And cardinality is just a fancy word for how many unique values are in each row. If you have low cardinality, that means there's like 1 or 2 unique values within your columns. High cardinality means there's a whole bunch. So in order to do this, what I'm going to do is I'm actually going to do an apply function on each one of my columns. And what I'm going to call here is I'm going to call x.unique. And this is, so basically this means, hey, for every column, go get me the n unique, which is the number of unique values. I'll run this, and each value here corresponds to the number of unique values that are within each column. So for example, there's 500 and, let me zoom in here, there's 571 species, and there's 15 Q care assistant, whatever that means. So now you can start to get a better feeling for how many unique values are there. Great. So let's take a look at a few min and max columns. And the way I'm going to do that is with just simply calling out one of these columns, which I'm just going to use tree ID. You can do this for any column you want. And I'm going to call min, and I'm going to call max, and then print it out in a print statement. So I can see that the min tree ID is 1, great, and the max is 262. Now, this is another reason why you're starting to get to know your data a little bit more. This 262 is a lot higher than the 194,000. So I'm guessing that there are maybe some trees that were removed from this data set because they were taken out or like replaced or something like that. And this is the total number of trees that have ever existed in San Francisco, whereas the 194 is the total number of current ones. And let's do the same thing for our tree dates. And so we get a better idea about when these are planted. And so I'm looking at plant date, min and max. Great, I have my plant date. The first one was in 1955, awesome. The most recent one, and this is as of when I was downloading the data set, was July 30th, 2020. And the last thing that we're gonna do is look at outliers. And so if I wanna get a better idea if there's any outliers in my data, I like to start with a box plot because that's easiest for me. And so I'm going to look at latitude and see if there's any outliers here. And I'll run this, and you can see here that there is this almost looks like a single data point, maybe a couple data points way up here, and the rest of the distribution is way down here. So yes, there are outliers within this data set. Let's look at the longitude. And yep, you can tell here there's an outlier that sits way down below, and the rest of the distribution is way up here. So yes, there's outliers, and we're going to need to take care of those before we can handle our data. And so that is the process. That's the start of the process of doing exploratory data analysis, which there is no right answer on how to do this. It's mostly how do you get to know your data better.